Everyone, welcome back to Pine Hollow Auto Diagnostics. Today we have another Chevy in the parking lot. Get a lot of these. It's my neighbor's farm beater slash ATV woods truck. And he said lately it's been running really poorly in the morning, misfiring, and then once it warms up it runs a little better. So he wants to get it back up to its full potential. On these trucks, I always like to connect the fuel gauge first thing, and also a scanner, just scan for codes. So what we have, let's see, so key on, just codes. Alrighty, mass airflow circuit signal low, camshaft position sensor problem, well, evap, fuel level sensor, transmission component slipping. Interesting. These three I'm not so worried about for the farm truck. These two I am, because they are actually drivability codes. So I guess let's do a couple of key on primes just to check fuel pressure, just to make sure we're to spec. So it looks like it's holding at 30. Crank it. So we're at about 40, almost 50. Snap throttle. It goes up. The throttle response, however, sucks. So I can see how the low power complaint is applicable here. So I guess we have to focus on these two: mass airflow and camshaft position sensor problem. So let's get out of here, look at some just data. And the truck is not really misfiring, but it's kind of lopey and not running quite right. You can see the fuel level. I don't know why that code's set. Maybe it's a history code. So engine data. We'll go for mass airflow and camshaft position. Mass airflow grams per second is 0.00. That's not good. Yeah, so okay. We have no mass airflow sensor signal reaching the computer. I'll rev it up a little bit. No change. And then cam retard right here. It says -60. And it's not changing. That should be varying, right around 0 if the distributor is set right and the cam chain's not stretched. But -60, that's not good at all. So in this case, I guess we'll get the scope out, since this mass airflow is a frequency type signal. Just back probe the mass airflow sensor, find the camshaft position sensor, back probe that, see if we have a signal there. I think that's the easiest thing to do. You might have several problems. Yeah, so it could be a wiring problem. If the signal is good at the sensor, we'll go from there. Alright, the mass airflow sensor, right here, 3 wires, and the pin out on the Varus here. We have the signal is yellow, the ground is the middle wire. It looks like a black with a white stripe, and the ignition positive, just 12 volts, is C, pink wire right there. So let's start up the truck and check all 3. Start with this positive wire, go back to our scope, it's a little sunny today, but I think it should be okay. And alright. Well, look, the fuel pressure is or fuel level. I guess it works. About 50 psi. And We're missing an ignition feed. Sure looks like it. There's your ground voltage. Do a little shake test. 0.04. And our signal. So that's 5 volts. So it's a pull down design. We unplug this guy. That should stay at 5 volts. Right there. So the computer is sending 5 volts to the mass airflow sensor, and that's going to pulse it to ground. However, we don't, I think, are missing an ignition feed right here. Yep, we're making contact, but so we have to pull up a wiring diagram to see what feeds this mass airflow sensor. So on BBB Industries, we have some wiring diagrams pulled up. There's our mass airflow sensor. Look at the ignition feed. It comes from ENG fuse 15 20 amp in the instrument panel fuse block. And what else does it feed? We have evap vent solenoid, purge solenoid, EGR valve. Also, check this out. There's our ENG fuse 5 again. Let's see, was it fuse 5 or fuse 15? It says fuse 15. S107. S107. So I don't know if they labeled it wrong, but that should be the same fuse. But check it out. It also feeds our oxygen sensor heaters, and they're directly grounded. So this is a kind of a dumber system. Turn the key on, the heaters are powered up all the time. And on the scan data, I noticed that it was not going into closed loop, and all the oxygen sensors were reading 0.5 volt, which means they're not functional and they're not being turned on. So again, all the signs point to this fuse right here, fuse 5 or 15 or whichever one it is, in the IP fuse block. So that's where we're going right now. One more thing, same fuse, ENG fuse 5 20 amp, feeds our camshaft position sensor. So all those codes seem to be caused by a missing power feed, a missing common power feed. So I'll just show you briefly on the oxygen sensors. So right there we have 4 oxygen sensors. They're showing 440 millivolts, and loop status is open. You can run the truck all day long here. It does start. So the long crank time, actually, if it doesn't have a cam sensor, it'll use just the crank to synchronize. That's why it's a long crank time. It all makes sense. But see, the oxygen sensors are staying at 450 millivolts. We're always in open loop. Obviously it's not using fuel trims. It's just running off of the map sensor and the crankshaft position sensor, because we're missing the MAF, we're missing the cam. So let's go to this fuse. It should be blown. So here's, it looks like the fuse panel is right here. Sweet. And we're looking for ENG fuse 5 or 15, whichever what the diagram said. So there's 5 ENG1, and 15 is not relevant, it's DRL fog light. So we're going for number 5, like that. And should be a 20 ampere, that guy right there. And yes, indeed, it is blown. Fantastic. Now the question is, why did this happen? Does this look familiar? Heat and vibration. We might have to go down to these oxygen sensors and take a look. Alright, let's do some testing at the fuse box. So I just have a jumper, positive and negative. This is a power probe adapter connected to a high power test light. This is a couple of bulbs. They're 2 amps a piece, so 4 amps just going through the bright bright filament. That's the green wire right here. Connected to battery negative, and we're trying to find the ignition feed right now. turn the key on. There we go. So the top pin on fuse 5, that's the ignition feed. And now what we want to do is connect the test light to battery positive here. So connect the test light to battery positive. You actually hear, you know, the computer turn on there since we gave it a feed. But let's go to, alright, so that's how much current is going through our test light right now. It's not as bright, so there's no direct short to ground at the moment, but according to this fuse, there was a direct short to ground at some point in time. So the plan of attack here is obviously a dual visual inspection, especially around the oxygen sensors. You know, it could be rubbing on some heat shield. This truck is all rusty and beat. That would not be surprised if that was the case. And if we find a short to ground, these test lights will glow a lot brighter. So right now we can measure the current. It's, I don't know, probably a few amps. So let's do that just for reference. All right, let's see how many amps we have, and we're going this way. About 2 amps right now. So half of the voltage is dropping across the bulbs. Half of the voltage is dropping across whatever accessories this thing is driving. Mostly it's the oxygen sensor heaters. That's the big current consumption here. So yeah, it's pretty neat. So if this is a direct short to ground, the test lights will light a lot brighter. We can actually just do a really quick check. So instead of going to the fuse box, we can just connect it straight to negative right here. This is the really handy thing about having this power and ground. And look, it's about 3.5 amps going through both bulbs. So twice as much current, almost 4 amps. Let's see, that's 0. Oh, come on. Sometimes this amp lamp is a little fussy. There you go, about 4 amps. Beautiful. So let's do a visual inspection and hook up our test lights and see if the brightness changes if we wiggle some harnesses around. So I've done a thorough visual inspection of the harness down at the oxygen sensors and up here in the mass airflow. There's the big loom here. Our lights are not changing brightness. I can't really find the short to ground at the moment. So in this case, we'll just put in a new fuse, take it for a spin, and see if everything is good. You know, clear the codes out and see if it's good. Sometimes fuses do blow because just of heat cycles. You get a little crack in there that heats up, and eventually it's just too hot, and they kind of, you know, blow because of age and just wear and tear. Fuses can do that. I've seen that before. So if you can't locate a short to ground by a wiggle test, visual inspection, the next best thing to do is just put the fuse in, take it for a spin on some bumpy roads, wherever, and see if it happens again. If it does, we'll chase the problem. If it doesn't, then, you know, give it back to the customer, tell them you found a blown fuse. If it happens again, bring it back, then we'll go further. But if there's no real problem, if it's just a fuse fault due to just due to age and heat cycles, then you fixed it. That's it. So let's pop in a new 20 amp fuse and go from there. Alright, a new 20 amper. Plug her in. Let's boot up our scanner, clear the codes, look at the data. Everything should work until this fuse either blows again or we fix the problem. Alright, so new fuse is in. Let's reset the codes. Oh, you can see our fuel gauge is on empty. That must be the fuel gauge code. Let's see, S10, okay, and engine, AT, okay, codes. Let's make sure we have the same ones. Yep. Let's clear them out. Clear codes. Yes. Okay. Start it up. Still at a long crank time there. Maybe better throttle response. Let's see. Display codes. No codes present. Back to our menu. Data. Look at engine data. See if we have a mass airflow signal present. Hooray, 5.7. And fuel trims. Look, our cam retard is minus 15 now. Let's go back to sensor data and see if our oxygen sensors are working. If it's in closed loop, fantastic. Our fuel trims are 3, short term 3, long term 11. Let's raise the RPMs a little bit. Those come right down. Not too worried about that. Let's take it for a spin. All right, let's go for a test drive. Oh, it starts right up. No more long crank time. Sweet. Just make sure we're not starting with any trouble codes. No codes present. Fantastic. The fuel gauge level is on empty, so that will probably come up eventually, but take it for a spin, see how it goes. Alright, just last check here, no codes. I've driven about 10 miles over potholes and rough lanes and grass, whatever. Truck runs great. So we're gonna hand it back to the customer, and if that was the problem, then they got lucky. And if the short to ground happens again, then we'll definitely dig deeper. But for now, just a standard 1 hour fee, new fuse, good to go. Alright, thanks a lot for watching. I'll see you in the next one. Bye-bye.